Hello children, I hope you have revised for your half-yearly examination. Now we are moving into our revision video. You know very well about your portions, right? The portion is our mechanics lesson and solid and fluid mechanics, right? So in that, what are the main areas of concern that we have written here? What are the main areas of concern? Definitions we need to see, sums we need to see, formulas, tabular column oriented questions, some application oriented questions, units, laws, constants. Constants means some numbers which you have to memorize. That type of questions I have categorized as constants, some flowchart based questions, and some questions will have point by point answers. That type of questions and some diagrams. Right? So that is what we are going to see. First we will see about the definitions. What are the definitions you need to concentrate more? Right? So first one, what is mechanics? Right? You have to study, it is the study of body in motion or at the rest, state of a body. So this is your part 1 definition of your unit 2. Right? So classworks you would have completed, you can move along with your classworks now. Right? So next one is, what is uniform motion? What is uniform motion? When a body covers equal distances in equal intervals of time. For example, if I am traveling 2 km in every 10 minutes, then without any change in the speed, right? Then I am said to be in uniform motion. A body covers uniform distances, equal distances in equal intervals of time. Right? So this definition is there in the part 2 of your mechanics lesson. Right? So what is force? Right? And what is elasticity? Plasticity? This definitions will come in solid and fluid mechanics concepts. What is elasticity? When a body regains its shape after removing the deforming force. For example, take rubber band. Right? When I stretch a rubber band, it gets elastic, it gets some elastic property and it gets stretched. When I remove that deforming force, the rubber band comes back to its original position. That phenomena is called as elasticity. Right? So this may come under second video of that fluid mechanics lesson. Right? Next one is define matter. What is plasticity? Just opposite to that of elasticity. If a body regains its shape, means elasticity. If a body doesn't regain its shape, then it is plasticity. Then what is stress? What is stress? It is force by area. Right? So you have to, when it is this type of definitions are asked, you have to write the formula along with the unit definition also. Definition, formula and unit must be there. So don't demand that the definition formula must be asked separately. Right? Next one, what is strain? Strain is change in dimension by original dimension, and you have to write no unit also. Right? Strain will not have any unit, that also you need to write. Strain will have no unit. That line you have to write. Then what are elastomers? What are elastomers? Which can be stretched to a long limit of elasticity. Right? They are called elastomers. This definition also I have given. And what is hydrostatics? Study of liquids which are at rest. Right? So what are fluids? So matter which can flow. Liquids and gases. Right? And what is viscosity and what is surface tension? For this viscosity and surface tension, write formula if you know. Surface tension, I have given a formula. Viscosity, as in the 7th standard, no need to write a formula. Only the definition alone you write. Okay? So definitions over. So sums and formulas I have combined together. Based on these formulas only you are going to get the sums. Right? So first pause the video now, right, just to see the board and write all the formulas, zoom the board and write all the formulas and practice it for at least for 5 times, each formula for 5 times. So what are the formulas? Velocity is equal to displacement by time, v is equal to s by t. Acceleration is equal to velocity by time, a is equal to v by t. Speed is equal to distance by time, s is equal to d by t. And I have written only one format here, 3 equations of motion. What are the 3 equations of motion? We have 4 sets, right? In that, all the 4 sets you need to practice. V is equal to u plus at, S is equal to ut plus half at square, V square is equal to u square plus 2as. Like this, you have 4 sets. Any one set or minimum 2 sets you need to get thorough. Okay? With signs, right? Signs means what? Plus or minus, SIGN. Okay? Then pressure is equal to H rho G. H rho means density, G means acceleration due to gravity. Then density is equal to mass by volume, rho is equal to m by v. Relative viscosity is equal to viscosity of liquid by viscosity of water. RV is equal to eta L by eta water, eta W, eta. Remember that symbol. Total energy is equal to P by rho plus V square by 2 plus 2G. Very important equation. This equation refers to Bernoulli's theorem. Right? So remember this equation very carefully. And F is equal to 6 pi eta AV. What law is this? Stokes law. STOKES. In this, F is viscous force, eta is coefficient of viscosity, A is the radius of the sphere. Take down that particular page in your class book and go through it. And V is called as terminal velocity. Right? And this is our second law equation. F is equal to ma, P is equal to mv. So basic equations which you have already learned in mechanics. Then impulse is equal to force into time, J is equal to F into T, surface tension is equal to force in by length, F by L, and right. Now these are all the formulas. Children, these formulas you need to get thorough, right? So now based on these formulas, I have written units here. So first shall we finish that, children? Now as per the formula, I have given the units here, right? Here we have, what is this? Displacement, distance, height. I have here, right? Displacement, right? Distance and height we have here, pressure formula. So for all those I have written units to be meter. Short form only I have written here. Units, symbols of the units. Meter and initial velocity U, V, S, speed. So that we have the unit meter per second. Where do we use initial velocity U, children? In the equations of motion, no. V is equal to U plus AT, there, right? So it is meter per second. Then acceleration is equal to meter per second square, units, right? Next, pressure is equal to Newton per meter square or Pascal. When you are writing Pascal, you have to write initial first letter to be capital P followed by small a. Remember that, okay? Then rho, density is unit kilogram per meter cube. Then what is G? G is acceleration due to gravity. What is this unit? Meter per second square. And whatever may be the unit for energy, whatever energy it is mechanical energy, chemical energy, heat energy, potential energy, kinetic energy. If that is the concept of energy, then unit is joule. When you are writing with full form, start with small letter. When it is capital letter, write it with single capital letter. Right? Then we have eta. Eta is viscosity. For that unit is Newton second per by, that is per means by meter square, or it is otherwise called as decapoise. This is otherwise called as Poiseuille. I think you hope you remember this. These questions may be asked in NEET based questions. But as of now, eta's unit is Newton second per meter square. Remember that. Other units and conversion you will see it in the NEET revision. Okay. Right. Now what is the unit for mass? Rho is equal to m by v. Mass unit is kilogram. Where volume, this is V, this V, right? Meter cube. Impulse unit is Newton second. How it is Newton second? Because impulse is equal to F into T. Unit of force is Newton, time unit is second. So that is why I have written Newton second. Right? Unit of momentum T, kilogram, meter per second. Surface tension unit is Newton per meter. Why it is Newton per meter? What is the formula for surface tension? F by L. F is Newton, unit of F is Newton, and by unit of length is meter. So Newton, meter is in the denominator, so it will go up. On this we have seen, right? So stress unit is Newton per meter square. Strain and relative viscosity, as they are ratios of similar quantities, they doesn't have any unit. So this also you practice. Pause the video, write it and practice it, right? So both the things you have to practice, right? Next one we have to see about loss. And children, based on these formulas, only we are going to do sums. 2 sums you will get. Okay, so practice all the sums, nearly more than 20 sums. Recently, the last teaching video also is based on sums only. So all those sums based on that model only are going to get, but numbers may be different or may not be different also. So practice all the sums. Okay, next one is laws. We have to see about laws. What are the laws we have seen? There are 3 laws of Newton we have seen. First law, second law and third law. When you are writing law, write the exact statement as I have given in the notes. First law of motion, second law of motion, third law of motion. Hooke's law. What is Hooke's law? Hooke's law states that ratio of stress by strain is equal to a constant. Stress within the elastic limit, applied stress is directly proportional to the strain. So that stress is proportional to strain. Stress by strain is equal to a constant. That equation also, you have to write the statement, the final equation. Stress by strain is equal to a constant. That equation also you need to write. Okay. Now then law of conservation of momentum. Right. So that also you need to know. And we can learn the Stokes law. Stokes law, that is this equation in which ends with F is equal to 6 pi eta AB. That also you need to practice. And finally you have to get with Bernoulli's theorem. Bernoulli's theorem will end with this equation. Where is it? Here. Total energy. So write the law, write the equation. Law, equation. Without the equation you won't get marks. So keep that in your mind. So now there are some diagram based questions, children. Graphs you have. There are 3 graphs in your mechanics lesson. Second video of that mechanics. Graphs for uniform motion. 2 graphs I have given. First and second graph goes for uniform motion. Third graph goes for non-uniform motion. Right? So done with 3 graphs, practice it. Next, some constants we need to remember. In this 3 equation of motion, and this pressure is equal to h rho g, and here we have small g. No. So what is the value of small g? 9.8 meter per second square. So this value won't be given in your question. You have to remember it. On the examination hall, don't raise this question. Question paper, this value is not given. No value will be given. You have to memorize it. Okay. Next one, pi you have. Where that pi you will get? In this formula. F is equal to 6 pi eta AB. This pi value is 3.14 or 22 by 7. So remember this also. That value also won't be given. Where the examination. Right? So flowchart, some questions are flowchart based. So what are they? We have mechanics, classification of mechanics. What are they? Rigid body mechanics, relativistic mechanics, quantum mechanics, right? And that relativistic mechanics is divided into statics, dynamics. So that classification, flowchart, and motion, random motion, oscillatory motion, circular motion. So that flowchart we need to practice, right? And some questions will have point by point answers. What are they? First was the equations of motion, 3 equations. And these 3 equations you have 4 sets. So practice it. And what are the factors affecting elasticity? So very important question. And what are the factors will affect the fixed volume? How matter have a fixed volume? How solids, liquids and gases have fixed volume? There are 2 points. This is the second question in your solid fluid mechanics part 1 video. Right? So practice it. And some tablet column based questions you need to learn. What are the differences between interatomic and intermolecular forces? This question I have not given like in a tablet column format. But as points I have given. If it is easy for you to learn as points, you go like that. Otherwise, if it is simple for you to write in tablet column, that also you can frame and write. Okay. Okay, it is your convenience. Right? Then what are the differences between density and relative density? There are 3 points given. All the 3 points you must learn. Right? Then what are the differences between attractive and repulsive force? This point also I have not given in a tabular column. Like theory based questions only I have given. So practice that. Say as it is you can write, or you can write in a tabular column format also. It is your wish. Right? Okay. Now some questions we have. Children, this questions is very important. So it may take a more weightage of marks. Okay. Right now, this application oriented question answers, that is what I have written at A.O question answer. Application oriented, which I have written here. No. Right. So some questions, what the concept we learn, we will apply it in our daily life. That question, what are they? Reasoning based questions. First one, why strain doesn't have any unit? Right? Because it is a ratio of similar quantities. That is the answer for it. Right? Then, how ink is absorbed in the paper? And why during rainy seasons walls get damped with water? Then, why sailors pour oil on the sea? That is, these are all due to surface. These two are due to capillarity. You can go through the content, and this is due to oil. Why do sailors pour oil on what? Sea? During storm, when they pour oil, effect of storm. Storm means what? Fuel, right? So that can be reduced so that ship can be saved, right? Even life will be saved, right? So that is the reason for it. Children, these questions I have given till here. These questions you can learn as it is from your notes, or you can write on your own also. If the reason is correct, I will give you full marks. Right? So then, some examples for surface tension. Daily life applications of surface tension. Very important question. This question, surface tension. So 5 to 7 points I have given, I think. So practice all the points. And then what are the daily life applications of pressure? Very easy. P is equal to F by A. That formula I forgot to add over here, children. Add that also. P is equal to F by A. Based on that formula, I have given few examples. So that examples you need to learn. So you can write, need not to memorize your big question, how I can learn. Don't fear like that. Application oriented questions only no. So directly you can learn on your own words. Okay. Next one, capillarity. So this example only. Absorption of ink, damping of walls, sponge absorbs the water. All these examples you can explain. Right? And the inertia, based on inertia and third law. What is inertia and third law? While I was teaching that lesson, I would have said, what is that? Driving. When you are traveling on a bus, when there is a sudden brake, you lean forward. Right? So that examples and all would have been given and asked the reason why. Right? So action and reaction, third law. Bullet fired from a gun works on which law? Like that question can be asked. Rocket can be asked as an example. So these questions is for your understanding. Only when you understand the concept you can do it well. Right? So these units we have discussed well. So children, first complete all these contents along with the sums based on this, right? Then go with your other contents. Finish this first, okay? So which will help you to get more marks. So practice well, learn well. All the best for your examinations. Thank you, children.